but I guess it's time to start. So, okay. Hi, my name is Hardi Niilo. I'm a team lead, interaction designer, and head of design systems at TWN, part of the Helmes Group. I've been working in the design field for over 15 years, and during that time, I have had the pleasure of helping to create many design systems for both the public and private sector. Most recently, I've worked on three major projects. We launched a new version of Estonia's national design system, bringing it from a pre-alpha prototype to a stable production-ready release. We built a design system for large supply chain platform using web components, making it possible for teams using both React and Vue to use the same components. And I'm currently developing a multi-brand design system for a project backed by two universities, making it possible to launch the same product under two completely different brand identities. Today, I'm going to show you what design systems are, how they help you save money by eliminating duplicated work, and how we brought Estonia's national design system from prototype to production, successfully automating the design to development handoff along the way. I'll also touch on how modern design systems support multi-branding rollouts and how they create the structure needed to integrate AI into your product development pipeline. And finally, we'll wrap up with clear practical steps you can take to get started in your own organization. Before we start, just a brief introduction to Helmes. Helmes is a digital transformation company with over 30 years of experience delivering business-critical software globally. And TWN is the design arm of Helmes Group with a special focus on UX, UI, and service design. Now, to help illustrate the impact of not having a design system, let me walk you through a quick example. It starts with something deceptively simple, a button, the humble button. It's the most basic UI component. You'll find it in every digital service, app, and website. But have you ever wondered how much does a button really cost? So, imagine you are building an online pet store and you need to add a button for adding items to the cart. Seems simple enough, but even this tiny component requires a surprising number of decisions. You have to give it the background color, text color, border color, font family, font size, padding and spacing, corner radius. You get the point. And that's just for the default state. To make the button actually feel good to use, you have to add interaction styles. How does the button look like when the user hovers over it? When the user presses it? How does it look for keyboard users? That's at least 3 more visual states, each with their own decisions. And your store will most likely need multiple variants of the buttons. For most important actions like add to cart, you need primary buttons. For supporting actions like add to wish list, you need secondary buttons. And for lower priority actions like read more, you need tertiary buttons. You'll also need different sizes. Most screens will use medium-sized buttons. For key calls to action, like checkout flows, you want large buttons. And for tighter layouts, like product cards or mobile views, you need small buttons. So pretty soon, you're looking at a list of buttons that looks something like this. Okay, so let's run the numbers. Let's say if it takes 32 hours to design, develop, test, and document a full set of production-ready buttons, and your hourly rate is 60 euros, then 32 times 60 gives us 1,920 euros just for buttons. Okay, fine, seems reasonable enough. But here's where it gets expensive. In most real-world projects, different teams often work on different parts of the same product, all in parallel. For example, in your pet store, one team builds the public storefront where customers browse and buy pet food. Another team develops the mobile app, which offers the same shopping experience on a smaller screen. And a third team works on the customer account area, where logged in users can track their orders and so on. Now, you might think, Come on, surely, it's easy. They can just share their components. But the reality is that without a shared design system, each of these teams ends up designing and coding their own versions of the same buttons, same decisions, same work done 3 times. So if we multiply our initial button budget by 3, we get 5,760 euros just for buttons on the same product. And those buttons, they likely won't match. You get slightly different hover styles, inconsistent padding, missing focus indicators. They look close, but not the same. And that inconsistency, it doesn't just affect visuals, it affects trust, usability, accessibility. And remember, buttons are the easy part. If you add in more complex components like tables, filters, models, the cost and inconsistency, it multiplies. In our experience, it takes at least 1,500 hours to design, develop, test a full set of production-ready components. At 60 euros per hour, that's 90,000 euros per product. And if each team builds their own, just like our earlier pet store example, the cost quickly balloons to 270,000 euros, all spent solving the same problems 3 different times. So without a shared system, you're paying for the same code again and again, and still end up with inconsistent results. And that's why design systems matter. They eliminate duplicate work. And it shows in the numbers. For example, Estonian Ministry of Justice and Digital Affairs has estimated that by using a centralized design system, they will be cutting their expenses by 20%, which makes roughly 1 million euros a year for them. IBM has reported saving over $3.2 million annually thanks to a centralized design system. And research done by Figma found that designers who had access to a design system completed their objective 34% faster than without the design system. So now we know why we need design systems. Let's take a step back and define what design systems actually are. Design systems are your organization's single source of truth for building user interfaces. They offer shared assets and guidelines that support every stage of digital product development. One of the core principles behind design systems is component-based design. So instead of designing full screens from scratch, interfaces are broken down into small reusable pieces like buttons, inputs, dropdowns, and each of these pieces becomes a component that is built once, then reused. Teams then assemble entire interfaces using these shared building blocks. A good design system has 3 key parts: reusable UI components for designers, reusable code components for developers, and shared documentation for everyone. And you really need all 3 for the system to work. You can think of it like a 3-legged stool. If you remove one leg, the whole thing just tips over. But when all 3 are in place, they give your product development the stability it needs to move fast and the boost to take it to the next level. For designers, the system usually lives in Figma as a drag and drop library of reusable components. Each component in the library is designed to match the brand's visual language, built with consistent spacing, typography, and color values. They come with all the usual interaction states, and they're flexible enough to adapt to different screen sizes and layout needs. So instead of recreating everything from scratch, designers build screens by snapping together approved components, kind of like Lego bricks. In addition to speeding things up, this approach improves usability by enforcing consistency across teams and products. It ensures that what's built in Figma actually gets built in code, because developers and designers are working with the same building blocks. And it frees designers to focus on creating innovative user experiences instead of redrawing the buttons over and over again. For developers, the design system lives in a shared code library, often documented in Storybook. It provides production-ready components that are centrally distributed and reused across apps and teams. They are version controlled to ensure stability and traceability, They are tested for accessibility, responsiveness, and browser compatibility, and they are fully documented for fast adoption and fewer questions. This means faster time to market, higher code quality, lower maintenance cost, and better alignment between design and development. The system removes friction so developers can focus on delivering value, not reinventing UI. And last, documentation. Often overlooked, but absolutely essential. Without clear documentation, even the best components won't deliver their full value. Documentation ensures that every team, design, development, product, content, Q&A, that they all speak the same language and they all operate with the same shared expectations. Documentation covers what components are available and when to use them, how to adapt them for different use cases, and guidelines for accessibility, branding, and content. For product managers, it improves planning and reduces ambiguity. For new hires, it shortens onboarding and builds confidence. We typically use tools like Zeroheight or custom-built portals to make documentation easy to maintain, access, and share. Now, there's one more key ingredient that we have to talk about, and that's design tokens. Design tokens are a way of making design decisions machine readable. So colors, spacing, typography, all stored as named values that can be reused, updated, and automated across your entire product. Tokens allow you to keep design and code in sync, automate updates across products, support theming and multi-branding. Now, let me quickly show you how color tokens are created. First, we start with a color audit. We can collect all the unique colors in our design. Next, we group them by tone, sort them by brightness. Then we assign raw color codes a name based on their tone and brightness. These named raw values are called primitive tokens, but we can't use them, not just yet. To make our system scalable and themable, we need another layer of tokens. These tokens are called semantic tokens. Their name directly tells you where they should be used. For example, button, primary, background, default. Finally, we connect primitive tokens to semantic tokens, and we're done. It's that easy. Now that we have a shared understanding of what design systems are, let me tell you the story of how we built the latest version of Estonia's national design system. In 2023, we partnered with the Estonian Information System Authority, RIA, to bring Estonia's national design system, VERA, to version 1.0. VERA actually had existed in some form since 2018, first as a PDF style guide, then as a loose Figma file. It was actually used in many projects, but adaptation was inconsistent since there were large holes in the design system. It lacked proper documentation, automation, and technical depth. Also, there were many alternative versions floating around. So our job was to take that early prototype and turn it into a stable, production-ready design system that the entire public sector could rely on. Based on the project brief and our design system experience, we worked with RIA to define 7 clear goals. We set out to save designers' time with ready-to-use Figma components, deliver HTML, CSS components that could be used in any front-end stack, automate as much of the design to development handoff as we could by using design tokens, elevate accessibility across public sector e-services by building it directly into the components, provide guidelines for inclusive and user-friendly content, deliver comprehensive documentation that brings it all together, and provide a fully thought-out dark mode to serve different user preferences. From day one, we knew that design tokens had to be at the core of the system, but we didn't actually know how we were going to implement them at this scale. We had some experience generating tokens from Figma using an in-house experimental tool. It worked technically. but it was really fragile, error-prone, and nowhere near reliable enough for a national design system. We briefly considered using a third-party tool called Token Studio, but the project rules explicitly forbade introducing any additional licensing costs. So that was off the table. But then, perfectly timed, Figma variables launched. Suddenly, we could create tokens directly inside Figma to store colors, spacing, and typography as structured data. That solved one half of the tokens puzzle for us. The other half was how to get those tokens into our code base. Figma actually offers an API for token exports, but that feature comes with a separate license cost. So again, not an option for us. So we built our own custom Figma plugin. This plugin collected all token variables, typography styles, graphic styles, and exported them as a machine-readable file, a format that our development tools could easily understand. And from there, the file was automatically processed and turned into style files for the web, which directly controlled how our components looked and behaved. And although Figma Variables was a beta feature, our early experiments were successful and we decided to use it for the whole project. But still, using tokens at this scale was new for us. So naturally, our workflows evolved over time. At the beginning, we worked the traditional way. Designers would build a component in Figma, apply tokens, fine-tune it, get client approval, and then hand it over to developers. It worked, but it created a bottleneck. Even though we had a clear list of components early on, developers were stuck waiting for finalized design specs before they could start. And this really held us back. But then something interesting happened. We were having a team meeting discussing how we could speed things up. And the lead developer on the project said something to the effect of, as long as you're using the right tokens, I don't care what you do in design. Typical developer attitude. But he was right. Because of the token pipeline, design decisions flowed automatically from Figma to code. If both teams shared the same token structure and names, we didn't have to wait for handoffs. So for the tail end of the project, this became our standard workflow. Designers and developers agreed on token structure. Developers set up basic building blocks in code, things like layout and placeholders for colors, borders, and spacing. Meanwhile, designers worked in Figma, assigning tokens and making the visual decisions. And when updates were ready, developers just pressed the button in the plugin, and all the latest design changes flowed straight into the code base. This shift was huge, and it was a real wow moment for me. We moved from sequential design development handoffs to true parallel collaboration, and it was all automated. And if we needed to make any changes in design, then it was a matter of minutes to get the updates to code. And this automated setup really paid off when we started building the dark mode theme. Instead of designing an entirely separate version of every component, all we had to do was to define a new variable mode. So if we go back to our earlier tokens example, introducing dark theme meant that there was now a switch to say which colors should be applied to semantic tokens. Same structure, same components, just a different look. And without tokens, we would have to create duplicates of every component and screen. This would mean twice the work every time something changes. But with tokens, we can simply switch between different visuals. And on the development side, it was just as easy. Plug in the new token values and everything updated on its own. So with tokens and a bit of structure, the technical part of theming was quite easy. And here's what Vera 100 looked like by the numbers. The project lasted for 7 months. We had a team of 8 specialists, and we logged around 2,700 hours. We created 104 reusable UI components, both in Figma and HTML and CSS, that were supported by 976 design tokens, of which 116 were primitive and 851 were semantic. And we backed it all up with 149 pages of documentation, covering everything from usage guidelines to accessibility and implementation details. But the real breakthrough, at least for me, was the automated handoff. Change the token in Figma, click export, and the code base updates. No extra licensing, no manual copying, no did you use the right blue conversations. Vera is now a shared infrastructure layer of Estonia's digital services. It allows government agencies to launch services faster with consistent UX, work across multiple front-end frameworks. It reduces duplication and design development misalignment. And we built all of this just in 7 months, fully within project constraints, using native Figma features and a bit of smart engineering. And we've now seen this in action. Since the launch of Vera 1.0, we worked on multiple public sector projects that use it as their design system foundation. And what's been immediately clear is just how much faster it lets us move. In many cases, we've been able to skip the usual early stage discussions about colors, typography, and branding because Vera already handles that. That means we can hit the ground running and focus directly on solving real business problems instead of spending the first weeks on defining a visual language. In other cases, clients have been eager to apply their own unique branding. And here too, Vera has proven flexible. Because the system is built around tokens, it's easy to swap out values while keeping the structure intact. We now have multiple projects where we've delivered full custom branded Figma libraries in around 180 hours of design time, which is about 85% faster than the original 1,200 hours it took to build Vera's design assets from scratch. And the same token-based approach extends even further. The logic that we use to implement light and dark mode can also power multi-brand design systems, where different institutions or product lines share the same structure, but use different tokens to reflect their own brand identity. In fact, we're currently working on a system that supports 3 separate brands, all built on the same foundation. So instead of light and dark mode, we now have brand A, brand B, and brand C, each with its own visual identity, defined entirely through token values. The structure remains the same, but the components take on a completely different look and feel. To support this, we've expanded and retooled parts of the Vera system, taking advantage of new Figma features and adding custom components to increase flexibility. But even with these updates, we're estimating around 330 hours per brand to deliver both design and code, which is still a fraction of the time it would take to build each system from scratch. And this leads us to AI. Today, AI tools are being used at every stage of the process, from generating wireframes to writing production code. And in many ways, design systems like Vera have already laid the groundwork for this shift. With Vera, we've seen it's possible to automate the design to code handoff at the component level. Designers apply tokens in Figma, developers press a button, and the latest styles flow straight into the code base. That alone saves hours of manual work. But there's still one step that takes time: stitching those components together into real user flows. At the moment, when developers implement full screens, they still need to open the Figma file, identify which components are used, figure out how layouts adapt to different screen sizes, and translate it all into responsive, production-ready code. That's where the next wave of AI tools is stepping in. Until recently, the only way to give AI any design context was by uploading a screenshot into a chatbot. But screenshots are just pixels. They don't carry meaning. The AI has to guess what it's seeing. Enter Figma MCP, or Model Context Protocol. MCP is a new open standard for connecting applications like Figma to large language models or LLMs. It gives AI agents access to real design data, not just visuals. And MCP was created by Anthropic, the company behind Claude AI. With the MCP, AI tools can now understand the structure of your design system, see the components, variables, and styles you've used, know what token controls a specific color or spacing, and access metadata like auto layout settings, component names, and even documentation. This context is sent to the AI as machine-readable data, not just images, and it makes code generation more accurate, faster, and cheaper in terms of LLM token usage. For example, say you've used a pink button in your design. Without MCP, an AI might create a new button based on how it looks in a screenshot. But with MCP, AI knows exactly which token was used, say button primary background default, and it can pull the correct value from the design system. Now, Code Connect is the second piece of the AI puzzle. It links your Figma components directly to matching code components in your repository. So instead of AI guessing which React or Vue component to use, it gets direct path to the actual code file. And this is really powerful. It means that when AI tool reads design made with real tokens and components, and your team has connected those components to code, it can automatically assemble real screens with real production-ready code. Not just buttons and cards, but entire layouts built from your own design system. We've already run small-scale in-house experiments with these tools, and the results are promising. So if you want to benefit from AI tooling, now's the time to invest in your design system. Because AI can't do much with scattered styles and copy-pasted components. But when your system is clean, structured, and well documented, AI becomes an accelerator, not a liability. So let's say you're convinced. You want to build a design system. Where do you begin? First, start with an audit. Take a deep look at your existing UI across platforms. Ask yourself, are we supporting just web or also native iOS and Android apps? What components are we using? And how many variations are there out there? Are those differences intentional or are they just inconsistencies? Can we break our UI down into smaller, reusable pieces? This step gives you a clear picture of your actual needs, not just what you think you need. Next, establish the fundamentals. Before you get into components, lock down the basics: color system, typography, spacing, icons. Then move on to core components: buttons, links, inputs, followed by more general content patterns like cards, tables, and lists. And after that, it's time to tackle your first complex component. I strongly suggest starting with the navigation and header. They're always harder than they look. There's lots of edge cases, lots of moving parts. Once those are solid, you can move on to tabs, accordions, models, and tooltips. And finally, show how it all fits together. Include examples of how to use these components in real-world layouts, because people need more than ingredients, they need recipes. Also, don't forget to bring development in from the start. Designers and developers should work side by side. You're not just building a library, you're building a system that must live in both design tools and in production code. And maybe the most important mindset shift: your design system is a product. It needs a budget, it needs a team, a roadmap. You'll need more time and resources upfront, but once the system is in place, it becomes an accelerator. Still, don't treat it as a one-and-done project. Someone has to maintain it, evolve it, support your internal teams, and keep it useful. And to recap, here's the full checklist. Start with an audit, establish the fundamentals, then tackle the complex components, show how it all fits together, bring development in from the start, and treat it as a product. And here's what you can do this week. Estimate how much duplication is happening in your UI work. List your top 5 most used components, and you can book a free consultation with us. We can help with strategy and planning, building your Figma libraries, front-end implementation, and training your teams. If you want to book a consultation, you can scan the QR code on the screen, or you can also find the link in chat or on the webinar registration page. If you scroll to the bottom, there's a button that takes you to the consultation registration form. And yeah, design systems aren't just a way to improve design. They're a way to reduce cost, increase speed, and prepare for the future. And we love to help you get started. Thank you.